Hello, this is Mr. White, and this video is about determining horizontal and vertical asymptotes, both algebraically and graphically. Please enter this function into your calculator. On a TI-84, you should be using the alpha F1 feature so that it looks exactly like this. On a TI-83, it should look just like this. I'm noticing that some students could afford to be a little bit more efficient in how they enter functions into their calculator. So for example, I've seen some students do things like this. Enter 3, and then they're adding in extra sets of parentheses for some reason. And then they're doing, instead of just typing 6x, I'm seeing things like 6 times x, etc. The extra parentheses, the times, that doesn't hurt, but I would urge you to strive to be as efficient as possible, to have your function look exactly the way that I have it looking up here for this example. If you've done so correctly, your graph should look something like this on Zoom Standard, Zoom number 6. So let's take a look at this algebraically. Now I wanted you to see graphically just real quickly, just so we could anticipate that we're going to see 2 vertical asymptotes and 1 horizontal asymptote. I wanted you to anticipate that, but again, let's now do this algebraically, and I'm going to do this a little bit quickly for the sake of trying to keep the video as short as possible. Students, again, I'm relying on you to tell me, to give me feedback. Am I going too quickly to the point where this isn't even useful? Is it just right? Is it too slow? Are you still missing things? Please give me that feedback. Okay, so algebraically, I'm going to do some things that should look quite familiar. We've done them before when searching for domain and range and doing various other things. But let's start by factoring the bottom. When we're looking for vertical asymptotes, we're going to find that the denominator is really where our focus lies. There are some rare exceptions where the numerator really comes into play, but I'll save that for another day. Let's focus on the denominator, and as such, I'm just going to put a squiggle here as a placeholder for the numerator. But on the bottom, I'm going to start by writing it in standard form. We find that a lot of times it's most useful to write it in standard form, which means that the exponents decrease. So here's an x squared term, followed by the x to the first power term, followed by the 6. So that's in standard form. And our next step, hopefully you're anticipating where I'm going with this, I'm going to factor out the greatest common factor. Now you may be thinking the greatest common factor, is that 2? Could be, but I'm going to say let's factor out a -2. I think that'll make our job easier in the end. And if I factor out a -2, that would leave me with an x squared. Again, hopefully you're anticipating, actively listening, anticipating what I'm going to say. Oops, I almost made a mistake there. Minus 2x, and then minus 3. And finally, let's factor that quadratic expression into 2 linear binomial terms. And again, I hope you're anticipating this, that this is going to be an x, this is going to be an x. Let's put a 1 here, a 3 here, and this will be a -3 and a +1. Now, when we're doing domain and range, here's where I could see some potential confusion. When we're doing domain and range, we said that this factor gave us the inequality that x could not be equal to -1. And we said that this factor told us that x could not be equal to +3. That's because we were talking about the function itself. And yes, in the function itself, x cannot be equal to -1 or +3. I'm going to erase some of this just to clear off some room for myself. But now we are trying to find the asymptotes, and the asymptotes represent these lines that the graph will never touch. So again, focusing on the vertical asymptotes. This is not the graph itself, these are the asymptotes, and the equation for this asymptote is x equals +1, and this one is x equals, I'm sorry, I messed up, x equals -1. My apologies, let me fix that. and x equals positive 3. Those are the asymptotes. These are the lines that the graph will never touch. So on the actual graph itself, just to get my color coding consistent here, for these blue lines, or these blue curves, these inequalities over here do hold true. Those blue lines will never have an x value of negative, those blue curves will never have an x value of negative 1 or 3. But the green asymptotes do have x equals negative 1, x equals positive 3. If I've lost you on that, please come seek clarification during office hours. That's the algebraic solution, and we've kind of are looking at it graphically as well here. Let's now algebraically determine what this horizontal asymptote is going to be, this one right here. All right, horizontally. Let me bring a graph onto the screen once again just to get the concept across. Notice that when I draw in my horizontal asymptotes, that the asymptotic behavior, the location where the graph is getting really, really close to this line, occurs over here and over here. We're not really focusing on the middle here. We're focusing on large values of x, large positive values of x, and also large negative values of x. And we will represent that by saying x goes to infinity. That's where the asymptotic behavior occurs over here. And as x approaches negative infinity is where the asymptotic behavior occurs on the left-hand side of the graph. So, with that in mind, let me move some of the clutter out of the way. And let's ask ourselves what happens as x goes to positive infinity. Now, what I found over the years seems to get across to students most effectively is to say, well, infinity and negative infinity, those are sort of these weird abstract concepts. So let's start by just thinking of what's a really big actual number for x. Let's say f of 1,000. Not quite infinity, of course, but it's a starting point. Let's say f of 1,000, and that's going to equal 3 times 1,000 squared, which is 1 million. Minus 6 times x, in this case 1,000, all over 6 plus 4 times 1,000, minus 2 times 1,000 squared, again 1 million. And I'm not going to break out my calculator at this point. I'm going to use some approximation. I'm going to say, you know what, this 3 right here is not very significant. It's pretty small compared to this 3 million. So for the sake of horizontal asymptotes, I'm just going to say that 3 doesn't really contribute much to this expression. Likewise, even though in some other problems 6,000 or negative 6,000 may seem like a big number in some other problem, when it's sitting right next to 3 million, even negative 6,000 is pretty small. So likewise, I'm going to cross that out and say that the bulk of the value here is coming from this 3 million. I'm going to do the same thing on the bottom, and I'm going to say that this 6 and that this 4,000 are pretty small compared to negative 2 million. Whoops. Okay, so now what I'm going to do is I'm going to say, now that I've crossed those out, I want to acknowledge that I've crossed them out, that they do contribute a little bit, but not a lot. So I'm going to acknowledge that by saying that f of 1,000 approximately equals, I'm using that squiggly equal sign to say it approximately equals 3 times a million on the top, all over, and that minus 2 million becomes negative 2 million. And now I'm looking at that and thinking, I can just cross this million on top and this million on bottom, divide each other out, and I'm left with negative 3/2. Now the question I ask you, listening to this, will the y value of this function here, will the y value ever equal negative 3/2? The answer is no, because remember, we've done these approximations. We've crossed out these terms that don't contribute much. Those terms do make a little bit of difference. So the 6,000, the 3, the 6 here, and the 4,000, those make a little bit of a difference. They will keep it from actually equaling negative 3/2. But we're just going to say that the graph gets very, very close. So if we look at the graph again, then I'm going to say as x goes towards really, really big values, so again, we're focusing on this part of the graph. As x goes in this direction, it is going to get closer and closer and closer to -3/2, a y value of -3/2. All right, if we did a similar thing for x approaching -infinity. Let me just reduce some of this clutter here. If I did a similar thing, I'm not going to go through that whole explanation again, but I'll trust that you can kind of fill in the holes here. If I said f of -1,000, I would come up with actually the same thing. It would really come out to the same thing, and I would ask that you just sort of do that yourself and verify that you believe that that would also approach -3/2. And I'll bring this back onto the screen and say what that is telling us, or what that is explaining, is why as we go to the left here, as we go to the left, that y value is also approaching -3/2. So the way we're going to write that, let me go ahead and go to the next screen here. To summarize what we found algebraically, we found that our vertical asymptotes were at x equals 3, x equals -1, and y equals -3/2. I'm not sure I ever put that y equals -3/2, but I'll put it there now. That is our horizontal line that the graph approaches. So let me ask you to now turn to your calculator again, and let's just verify that. Let's make sure that graphically we are 100% in agreement with our algebraic results. So here's my calculator. Computer's being a little bit slow bringing it up, but here we go. I've entered my function. And let's explore this x equals -1 here. If I go to trace and I type in -1, hopefully you anticipated this, that there's no value here for the y. It's telling us that the graph itself doesn't have an x value of -1. Likewise, if I were to go to x equals 3 here, once again, there's no value. Now we should know that if I type in a value that's really, really close to that, hopefully you can anticipate what's going to happen. Do you know? 2.999, hopefully you anticipated that I'm going to get a really, really big value. And we've done things like this in class. Hopefully that makes sense why. If not, please take the time to ask for clarification, because this is a major point. So we've done things like this with the vertical asymptotes. So I'm not going to elaborate any further on that. What we have not explored as much is the horizontal asymptotes. So let's really kind of focus on this y equals -3/2 here and how to verify that. I can start by going back to trace, and I can start hitting the arrow buttons. And as I go to the right, and you see the cursor here on the calculator going to the right here, does that y value approach -3/2? I'm looking right here on the calculator screen. Is that approaching -3/2, which we know as a decimal is -1.5? It sure looks conceivable, doesn't it? And as I keep pressing the arrow button, the calculator will adjust the screen accordingly. But this is taking a while, so I'm going to say let's use our table to really just get there more quickly. Let me show you what I'm referring to. Let's go to our numerical model. Let's go to second table, and depending on your calculator, you may see something like this. If I arrow up on the table, I'll see other values. If I arrow back down, I can get it to scroll back down. Notice the two errors here. That's where our that's where our vertical asymptotes were, right? X equals -1 and x equals 3. But I'm wanting to go to really, really big values of x, and kind of like scrolling on the graph, this is taking a while. So here's the trick that I'd suggest. Go to second table set, which is right above the window button. And notice that when we go there, we can just type in a really big number. So let's type in that 1,000 that we were talking about earlier. And then when I go back to table, second table, as always, I hope you're following along here to get the most out of these lessons. Now it's jumped right over to 1,000, and I'm seeing that the table is saying that it's actually achieved negative 1.5, but let's arrow over that and look down here in the calculator. Notice that no, it didn't really get there. It just got really, really close. These columns in the table didn't have enough room, but it's got really, really close. Likewise, if I wanted to go to the left, I could go to second table set, and I could type in negative 1,000, go back to the table, and once again it looks like it's achieved negative 1.5, but if I arrow over I can see that no, it's just gotten really, really close, and it'll never reach it. So I hope that made sense. We've explored this and verified this graphically after doing it algebraically. Let me ask you to go ahead and try this one on your own. You know the drill by now. Try it to find the vertical and horizontal asymptotes algebraically first, then graphically. Go ahead and pause the video because in just a second I'm going to reveal those solutions. All right, let me go ahead. Here are the solutions. You should have a graph that looks something like that. You should have vertical asymptotes, x equals -2, x equals +5, and you should have a horizontal asymptote of y equals 11/3. After you do a number of these horizontal asymptotes, you should be able to look at this result, look at this original function, and kind of draw some conclusions about how we might predict that pretty quickly. But I'll leave that for another day.